7 is going to ask us to fill in the blanks for this MATLAB function called sigma sum. It's going to take any positive integer n, and it's going to find this series sum with x as acting as a vector. So our output is also going to be a vector, and the output is going to be called y. So we have to fill in the blanks for this loop with only arithmetic and no built-in functions, and we're not allowed to use this power function as well. So use only variables defined below. So it defines p of x for us, and it says x times x times x. So that's this right here. And then we have p of 3 equals 3. So that's this right here. And then factorial equals 24. So that's this right there. And then y equals the whole thing basically computed. So that's going to be our running sum. So that's the whole of this, which is going to be the series. So that's going to be our running sum. So let's start filling in the blanks. So it says for I equals something, and this will cover all values in vector x. So since x is a vector of, I'll just say like 1, 2, 3, 4, etc. So it has a certain amount of values. So if we want to cover all the values of x, we want to cover from 1, which is the first value, all the way till the final value of x. And so we're looking basically at the amount of elements x has. So in order to find the amount of elements x has, we just say length of x. That will give us the amount of elements it has. That will also tell us how many is in there, and therefore we know when to stop counting. So if we say 1 through length of x, that's basically saying if x was 4 elements, that's 1 through 4. So that's an example right here, right? So we can say I equals 1 through length of x, and we're allowed to do this. We're not using inbuilt functions within the loop. Then it says for j equals, and this will get the sum for each x. So we know that at each x value, we're going to have to compute this entire series with whichever the number n is. So just a note, when we're looking at our initializations, it says x times x times x for p of x, correct? That means that's x cubed. And we know this is equal to x of n plus 2. So that means n, that if we solve for this, n must equal 1. That means we started off at n equal 1 already. So we don't, if we say 1 through n, that's incorrect. We can't say this because we've already started at 1. And that means we're repeating something that we shouldn't be doing. So we start off at n equals 2, all the way through whichever n is. And so that will get us our correct thing, because when we start writing this out, you'll see how this works. So we'll say we have to continue our running product. So we say p of x equals p of x times x. That's what's happening over here. Every time I is increasing, we're multiplying by another x. And we have p3 equals 3, or p3 times 3. Because if we have 3 to the n, every time n increases, we're multiplying by another 3. And then we say factorial, or fac, equals to fac times, and then whatever is being multiplied each time. So if we say j plus 3, we're basically saying that when j starts off at 2, we're multiplying by 2 plus 3, which is 5. And factorial over here is equal to 24, which is essentially 4 times 3 times 2 times 1. And so we want to multiply it by the next number, which is times 5. And then same thing when we go through j equals 3 over here, we're going to multiply by another x, another 3, and then if j is equal to 3 here, we have 3 plus 3, we get 6, we multiply by 6. We want to keep continuing that factorial. So that's how you keep that going. Then we want our running sum, so you get y equals y plus p of x divided by parentheses p3 plus factorial, and end that parentheses. So this is how we're going to write it. So let's review it. So we're saying for 1 through the last element of x, for every single element of x essentially, we're going to go through j, or basically it's going to represent I over here, j of 2 through n, because if we say 1 through n, that means we have to initialize it at a different number over here. Like if we said p of x was equal to x times x, then it's okay for us to say 1 through n. But the problem already started at x times x times x, which means I already started at 1, so we have to start at 2 over here. And this will go through the amount of number of iterations n that we want. So we have p of x, and then we're just going to multiply by x again. And then for p of 3, we're going to multiply by 3 again. And for factorial, we're going to multiply by the next factorial number again. And then we're going to add our running sum by having our old sum plus our new term. And that will be how you do number 7.